Hello students, these are topic tests by Bodhee Prep for quant. The idea of these topic tests is that once you cover the basic concepts of a topic, you want to check whether or not you're able to apply those concepts in a test or an exam format. That is where you take these tests the moment you cover a topic. With every test, there is a video. So once you've taken the test, you refer to the video, get the solutions, and a brief analysis of what should have been a good attempt for that test. There are more than 200 such topic tests available on the Bodhee Prep Android app. The link for the app is in the description below, so make sure you download the app and make the most of these tests. This video is about the topic integral solutions and inequalities. This is the second test on the topic that is being discussed. In terms of oral analysis, the test I think was a difficult test in 5 to 6 questions, net correct. It would give you a 95 plus percentile. Attempt time for these questions would be about 23 minutes. So going from question 1 to 10 and getting a 5 to 6 correct should happen in about 23 minutes time. If we do look at the questions, the first one says, how many positive integer values of a are possible such that a plus 220 is in upon a plus 4 is an integer. Now a plus 220 can be written as a plus 4 plus 216 upon a plus 4. This becomes a plus 4 is divisible by a plus 4, so 1 plus 216 by a plus 4. Now for this to be an integer, 216 should be divisible by a plus 4. 216 is nothing but 6 cube, which is 2 cube into 3 cube. So the number of factors of 216 will be 3 plus 1, 4 into 4, which is 16. And therefore, a plus 4 can take any of these 16 values. But the point is, a has to be positive integer. Therefore, a plus 4 has to be greater than equal to 4. Since a is greater than equal to, not equal to, positive integer. Since a is greater than 0, a plus 4 has to be greater than 4. Now, in these 16 factors, if you look at 216 factors, the factors would be 1, 2, 3, 4, 6, and so on. The first 4 factors will not be counted. We'll start counting from a plus 4 is equal to 6, which will give us a as 2, which will be the smallest value of a. And from there, we'll start counting. And therefore, the number of solutions possible is 216 has 16 factors, out of which 1, 2, 3, 4 are not greater than 4. So 12 values are possible. I would say this is an easy to moderate question because breaking this down into 1 plus 216 upon a plus 4 is not very difficult. And then checking for factors is also something that we've done enough to not be flustered by it. 2 to 2.5 minutes to solve the question. P4 is less than equal to P is less than equal to 9, minus 0.25 is less than equal to Q is less than equal to 0.36. Minus 0.49 is less than equal to R is less than equal to minus 0.01. R upon S square is equal to P square upon Q, where P, Q are and S are real numbers. What is the difference between the maximum and minimum possible values of S? Now from here we can say S square is equal to R into Q upon P square. S square, this value always has to be positive. P we know is a positive value. Q we know is an always negative value, and therefore R also has to be a negative value. Only then will S be real. Also, if we want to maximize S, what we can do is we can take the maximum negative values of both R and Q. So point R becomes minus 0.49. R was always negative, and therefore we'll take Q as negative as well. Always negative, we'll take this negative so that the product becomes positive. R becomes minus 0.49 into Q becomes minus 0.25. Most negative value. Taking the square root will increase the value of the number. 0.16 if we take, it will be 0.4, 0.25 will be 0.5. Divided by the smallest value for P will be 4. And therefore, if we take the square root, we get plus minus S is equal to, this becomes positive, so 0.7 into 0.5 by 4. And therefore, maximum possible S will be 0.35 by 4. And minimum possible S will be minus 0.35 by 4. The difference between them 0.35 by 4 minus 0.35 by 4, which will be 0.7 by 4 or 0.1 0.175. None of these becomes the answer. I think easy question, putting values and solving, about 2 to 2.5 minutes to solve. If x cube minus 5x square plus 7x minus 3 into x cube minus 5x square plus 8x minus 4 is upon 2x minus 2 minus x square into x square minus 3x plus 2 into x square plus 3x plus 4. 3x plus 4. B square minus 4ac. B square minus, where x is a real number, which of the following is correct? First, let us look at the quadratics. Here we can put values also for x. For example, if you put x as 0, minus 3 minus 4, 12 upon minus 2, 2 and 4. We'll get a negative value. So 0 should not be in the range. From there, we can cancel the solution. Here we can take a large value of x and put it. But the only problem is there is none of these options available. So therefore, we might not get a sure shot answer. We might be able to eliminate options, but we cannot be sure that the answer left is a sure shot answer. Therefore, you're factorizing for the first one, x cube minus 5x square plus 7x minus 3 is equal to 0. If you have to factorize, the product of the sum of roots is 5. Say the roots are a plus b plus c. A plus b plus c is 5 and a into b into c is 3. Now the numbers that satisfy this can be 1, 1 and 3. If we put it as ab plus bc plus ca, we will get 1 into 3, 1 into 1, 1 into 3, 1 into 3, which is 6 plus 1, 7. Minus plus minus. And therefore, the first quadratic can be written as x minus 1 into x minus 1 into x minus 3. The second one, x square, x cube minus 5x square plus 8x minus 4 is equal to 0. The sum of roots a plus b plus c here is 5. The product of roots abc is 4. Three numbers is satisfied. This can be 2 to 1. If we look at ab, bc, ca, 2 to 1. 2 into 2, 2 into 1, 2 into 1. 4 plus 2, 6 plus 2, 8. Which is the third value. And therefore, the second cubic can be written as x minus 2 into x minus 2 into x minus 1. Upon x square or minus x square minus 2 plus x. Minus x square plus x minus 2. If we look at the discriminant for this, b square minus 4 into minus 1 minus 2, which means 1 minus 8. Discriminant is less than 0 and the coefficient of a or coefficient of x square is also less than 0. Therefore, we can say x square plus x minus 2 is always less than 0. It will not have real roots and it will be downward sloping. Therefore, will always be lower than the x-axis. This therefore is always less than 0 or a negative value. If we look at x square plus 3x plus 4, this sequence is always positive because here b square minus 4ac is less than 0 and x is positive. So this is always positive, this is always negative. X square minus 3x x square minus 3x plus 2 can be written as x minus 2 into x minus 1 minus 3 plus 2. Now if we multiply this on the right hand side, nothing will change because this value is always positive. If we multiply this value on the right hand side, the sign will become inverse, and therefore we can say this is less than equal to 0. X minus 2 cancel, x minus 1 cancel. So x cannot be 2, cannot be 1. X cannot be 2, cannot be 1. X is not equal to 2, x is not equal to 1. And therefore we are left with x minus 1 whole square into x minus 2 into x minus 3 is less than equal to 0. If we look at this, the critical points are 1, 2, and 3. Positive, negative, positive. Since it is 1 square, so the sign will not change. So the only range where this is negative is between 2 and 3. But the point here is x should not be equal to 2, because if x is equal to 2, this becomes 0. 4 plus 2 minus 6. The denominator cannot be 0, and therefore the correct answer will be D, which would be x is 2 to 3, where 2 is not included in the answer. So option D becomes the answer. I'm saying a difficult question. There are cubics to be factorized. We have to look at quadratics being always positive, always negative. And then the answer also has a root which should not be part of the answer. And therefore, 2.5 to 3 minutes easily to solve this question. A difficult question overall. What is the number of non-negative integer solutions? Non-negative integer solutions for the equation x square minus xy plus y square is equal to x plus y. This can be written as x square minus xy minus x plus y square plus y is equal to y square minus y is equal to 0, which means x square minus x into y plus 1 plus y square minus y is equal to 0, which means x square minus 2 into x into y plus 1 by 2 plus y plus 1 whole square by 2 square minus y plus 1 square by 2 square plus y square minus y is equal to 0. This becomes the square of x. So x minus y plus 1 by 2 whole square is equal to y square minus y square, y minus y square plus y plus 1 whole square by 4, which means x minus y plus 1 by 2 whole squared is equal to 4y minus 4y square plus y square plus 1 plus 2y upon 4, which means x minus y plus 1 whole square is equal to, this becomes, this is 4y plus 2y plus 1 plus 6y minus 3y square plus 1 upon 4. Taking the square root, x minus y plus 1 by 2 is equal to plus minus root of 1 plus 6y minus 3y square upon 2, and therefore x is nothing but plus minus root of 1 minus 6y, 1 plus 6y minus 3y square plus y plus 1 upon 2. Now, for x to be real, non-negative integer, okay. So yeah, it is a real value. We have the root has to be greater than equal to 0. 1 plus 6y minus 3y square should be greater than equal to 0, which means 3y square minus 6y minus 1 should be less than equal to 0, which means y will be, the critical points will be 6 plus minus root of b square minus 4ac 12 upon 2 into 3, which is 1 plus minus, this becomes 36 plus 12, approximately 7 upon 6. So this will be 1.16, 2.16 and minus 1.1, minus 0.16. So y here could be, since y has to have integral values, for this to be true, if we put y as less than 0, if we put y as minus 1, this becomes 1 minus 6 minus 3, which is less than 0. As the value of y increases, minus 3y square becomes negative value. So it has to be between minus 0.16 and 2.16. Positive, negative, positive. If approximately there, if y is 0, this is positive, but we are looking at non-negative integers, so 0 is not possible. If y is 1, 1 plus 6y. 1 plus 6 minus 3 is positive, so 1 is a possible value. If y is 2, 1 plus 12 minus 3 into 4, 12. This is also positive, so 2 is a positive value. If we put 3, 1 plus 8, 18, 19, and here we'll have 27 negative. The only possible non-negative integer values that y can take are 1 and 2. If we put the value of 1 and 2 here, non-negative integer, 0 can also be used. 0 will also be a positive valid solution because we're looking at non-negative. So y can be 0, 1 or 2. Now if we put y as 0 here, we will get x square minus 0 plus 0 is equal to x, which means x square minus x is equal to 0, or x into x minus 1 is equal to 0. So if y is equal to 0, x could be 0 or 1. Hence, y is equal to 0 implies x is equal to 0 or 1. If we put y as 1, we'll get x square minus x plus 1 is equal to x plus 1. So x square minus 2x is equal to 0. Or x into x minus 2 is equal to 0. Which means y is equal to 1 implies x could be 0 or 2. Is this correct? X square minus 1 minus x plus 1 x plus 1. If we put y is equal to 2, we'll get x square minus 2x plus 4 is equal to x plus 2, which gives us x square minus x plus 2 is equal to 0. P square minus 4ac. P square minus 4ac will be negative and therefore x will not be real or integral for that matter. P square minus 8 minus 7. And therefore 4 solutions are possible. 0, 0, 1, 0, 0, 1, 2, 0. Again, in terms of level of difficulty, I would say difficult question. Completing the square and then finding solutions. Easily 2.5 to 3 minutes to solve. How many positive integer pairs xy satisfy root of x plus root of y is root of 2003? Now suppose x was of the form a square b and y was of the form c square b, where b was a prime number. Then root of x plus root of y could be written as a square b plus root of c square b, which would be a root b plus c root b. And therefore, we could write it as a plus c into root b. Now, we have 2003 here. Therefore, a plus c into root b, where b is prime, is root of 2003. The problem is 2003 in itself is prime. And therefore, b becomes the value 2003, which means a plus c has to be equal to 1. The only possibility is a is 1, c is 0, or c, a is 0, c is 1. In both cases, a and b will not be positive simultaneously, and therefore 0 positive integral solutions are possible. I'll call this a easy to moderate question because 2003 being prime makes the job a lot easier. About 2 minutes to solve. The solution set for 5x plus 2 mod is less than equal to 10. Okay. Now, mod of x less than equal to a, the solution is minus a less than x less than a. So here we write minus 10 less than equal to 5x plus 2 less than equal to 10. Subtract 2 from the entire thing, minus 12 less than equal to 5x less than equal to 8. Divide by 5, minus 12 by 8, 5 is less than equal to x is less than equal to 8 by 5. And therefore option D simply becomes my answer. Yeah. Easy question, not more than a minute and a half to solve. Standard solution process. 89y minus 273x is equal to 40. What is the sum of x and y? Both x and y are natural numbers less than 100. 89y. 89y is equal to 40 plus 273x. Y is equal to 40 plus 273x by 89. Now, 40 divided by 89 is a remainder of 40. 273 by 89. 89 into 3 is 240, 267. So this gives a remainder of 6. Therefore, we can say when this division happens, we get a remainder of 40 plus 6x. Now, this should be such that we reach 89. That is when the remainder will become 0 and the numerator will be divisible by 89. Obviously, 89 is not possible because even, this is odd. If we make this even, multiply by 2, 40 plus 6x, we are looking at 178, which means 6x is equal to 138, x is equal to 23. So when x is 23, numerator will be divisible by 89, and in that case, y will be 40 plus 273 into 23 by 89, which means y will be 273 into 23 plus 40. Can do this directly. Hmm. 273 into 23 will be 819, 546, 6279 plus 40 will be 6319. 6319 by 89. 8 7s are 56. 7 8 7s are 63. 36. 36 62. 89. 630 minus 7. 623. 8 and 9. 71. And therefore, a solution for this is when x is 23, y is 71. All other solutions, the value of x will not be in the range 100 and the value of y will also not be in the range 100 because the coefficient of x added or subtracted from 71 changes the value beyond 100 and so does the coefficient of y. So what is the sum of x and y? The sum of x and y, the only possibility is 71 plus 23, which is 94 becomes my answer. I think moderate level of difficulty. All we have to do is look at the remainder and from there it becomes a lot easier. About 2 to 2.5 minutes to solve the question. If three positive numbers ABC, positive numbers ABC are such that A is less than 40, B is greater than 60, C is less than 20. Positive numbers. So A would be anything from 1 to 39. B would be anything above 61, 61 included. And C would be anything from 1, again, 1, not necessarily, anything above 0. Anything above 0 to 19. Which of the following is definitely false? A minus B plus C is less than minus 10. Again, if we take A as 19, B as minus 100, A as say 1, C as 1, and A as minus 100, we see that this is minus 98, which is less than minus 10. So this can be true, not definitely false. B minus 3C is greater than 20. If we take B as 100, C as 1, 97 is greater than 20. So this can also be true, not necessarily false, not always false. 2C minus B has to be less than minus 20. If we take C as the best possible case, we're looking at negative. B is negative. If we take C as 1 and B as minus 100, we get minus 98, which is less than minus 20. So this also can be true, not definitely false. Hence, none of these becomes my answer. Easy question, put in the values and get the answer. 1.5 to 2 minutes to solve. Find the number of ordered pairs AB which satisfy the equation AB is equal to 2A plus B. AB is equal to 2A plus 2B. AB minus 2 minus 2B. 2A minus 2B is 0. AB minus 2A minus 2B plus 4 is equal to 4. Multiply the coefficients of A and B. Add on both sides. This can be written as A minus 2 into B minus 2 is equal to 4. Now, A minus 2 can be written as 4. B minus 2 can be written as 1. A minus 2 can be written as 2. B minus 2 can be written as 2. Three factors. A minus 2 can be written as 1. B minus 2 can be written as 4. They are integers, so they can also be negative. A minus 2 can be written as minus 4. B minus 2 can be written as minus 1. A minus 2 can be written as minus 2. B minus 2 can be written as minus 2. Integers, ordered integers. A minus 2 can be written as minus 1. B minus 2 can be written as minus 4. Basically, 4 has three factors 1, 2, 4. And therefore, negative also minus 1, minus 2, minus 4. A minus 2 can take any one of these 6 values. Correspondingly, B minus 2 will take the remaining 6 values. Or the corresponding 6 values, and 6 ordered pairs A and B are possible. 6, 2, 3, minus 2, 0 and 1. Again, I'd say easy to moderate question. The numbers are simple, and we have done these questions earlier when we talk of 1 by x plus 1 by b is equal to 1 by 6. The process kind of remains same, and therefore about 2 minutes to solve. If n is a upon b plus c plus b upon c plus a plus c upon a plus b, where a, b, c are the three sides of a triangle, which of the following best describes the range in which n lies? Now, the minimum value of n will be when these numbers are as close to each other as possible, and therefore when a, b, c is are sides of an equilateral triangle. So a is equal to b is equal to c. In this case, n will be a plus a plus a plus b plus b plus b, because all sides are equal. C plus c plus c. This will be 1 by 2 plus 1 by 2 plus 1 by 2, which is 3 by 2. And therefore, the lower range, the value of the sum being minimum, will be 3 by 2. If we look at the maximum value, we look at an extreme case where A and B are very, very large sides and C is a very small side. So A is approximately equal to B and C is approximately equal to 0. In that case, A plus B plus C plus B plus C plus A plus C plus A plus B. Since C is almost even, A is almost equal to B, this will just be less than 1. Similarly, here, this will just be less than 1. And this will be almost 0 because C is 0. And therefore, this sum will be just less than 2. And therefore, the overall range will lie from 3 by 2 included to just less than 2. Option A becomes my answer. We are looking at different cases, two extremes being when A and B are completely different values versus when A, B, C are very similar values. I think moderate to difficult question, 2 to 2.5 minutes to solve. Unless you know where you're going, you will have to make multiple cases, which will take time. So if you look at the overall test, as I was saying, difficult test, 5 to 6 questions should be sufficient. And if I have to get my 5 to 6 questions, they would be for me 1, 2, 6, 8, 9, 10. Which are these? This I think is simple. We're just looking at factors of 2, 1, 6. Here also putting values, eventually we do get an answer. This I think will take time, might not be something that we are able to solve every single time. Again, I think this is a difficult question. Here, the question is not very difficult, but unless you understand 2003's prime, it will not work. So not counting this question. This is a standard process question. We'll solve it every single time. Similarly, here, we were looking at just the denominator, the remainders, and therefore, even if it takes time, it will eventually give me the answer. This, I think, should always be attempted. We're just putting values and checking. This question again was similar to what we've done earlier, therefore can be counted. Seventh, I would not count as one of the questions, sorry, because even though the process is simple, it might not happen for all the numbers every single time. It might take time. For example, here we had the second multiple of 89, which gave us the answer. That multiple could have happened at steps of 4 or steps of 6, which would make it difficult. 8 is counted, 9 is counted. And rather than 7, I'll count 10 because here I will keep putting values and eventually I will reach an answer. And therefore 1, 2, 6, 8, 9, 10 becomes my pick of the 6 questions.